Welcome, yeah. So today's lecture is based on from your Form B course plan. You can see the OSPF, right? So OSPF is an acronym for Open Shortest Path First. So OSPF is used to share router information. Later we'll look in detail what it is, yeah. So you have multiple routers connected to each other. As we know, routers are separate networks, right? So the routing table information needs to be shared, right? So because just a recap, the routers only know about the networks that is directly connected to it. So in order for other routers and itself to know about other remote networks, so routing information or from the routing table needs to be shared, right? So one of the protocol that's been used for this is called OSPF, Open Shortest Path First, right? It's one of the interior gateway protocol that can be used not only to share information, but part of the information is also to detect which is the best route. Okay, if you need to forward a packet, the router need to make a forwarding decision. What is the best path between source and destination, right? So it's using an algorithm by Dijkstra. I believe you guys know Dijkstra already. He came up with a lot of very good algorithm in computer science. So one of this is shortest path first algorithm. So that is the algorithm that is employed by OSPF, right? Right. So it's basically sharing link state advertisement. Okay, that means not only routing table but also the state of its interface and its status up or down, or also the IP address for that particular interface. So all these things basically part of the information that's going to be shared by the router. So there will be information we need to know about the designated router and the backup designated router. So if the main DR goes down, the PDR also the backup one will come to take its place lah. All right. So there's a lot of information here in this chapter. Any question? Please raise up your hand. Okay. I will pause to check your question. Yeah. Or you can straight away ask me. Okay. Use your mic to ask me straight away. All right. So let me start off with this. Okay, and let me record our session so you can refer back later. Yeah. All right. So we focus on single area OSPF version 2 configuration. Right, single area. So this is basically we're going to look at the backbone area or the most core area of OSPF, right? There are few areas, and depending on the areas, the operation OSPF change a little bit. Other areas are sub area, not sub areas, transit areas. Okay, so but we focus on backbone area first, yeah. Right, so let's begin. Okay, so the topics inside this chapter is configuration of the OSPF version 2 router ID. This is to identify that router. So each router will have their own router ID. So we're going to look at how to configure the router ID. And then there are two types of networks that we're going to look at. One is point-to-point networks. Simply means one router is connected to another router. All right. So that is called the point-to-point network, right? So it's different when we consider multi-access network. So OSPF, we can perform some customized configuration based on what kind of network we place our router in. Is it a point-to-point network where maybe you use a serial cable to connect two routers together, so point-to-point, or we use a switch, yeah, switch to connect multiple routers together. So that will be multi-access, right? So in multi-access, we need to know who is the main router, right? So there will be a designated router and the backup designated router election for that one, right? As you can see here, okay? DR-BDR election in multi-access network because there are more than two routers, so we need to know which is the main router. All right, and then we look at how to modify single area OSPF version 2 to change the operation of that single area OSPF version 2, right? And then we look at default route propagation, configure our OSPF to propagate a default route. How do we configure that? Yeah. And finally, as usual, after configuration, we need to verify our implementation. All right, so we'll start with our SPF router ID. This is to identify our router. Now, we're going to be using this topology here, okay, in our example. Please note that there is loopback interfaces. Okay, so loopback interfaces are basically interface that's virtual. It's created in the router in software. Yeah, it doesn't represent a physical interface. When I say physical interface, it's basically the hardware interface where you can plug in the cable, right? So this loopback interface is a software-based virtual interface, but it works similar to any other interface, right? Why loopback interface is important? Because there are many reasons. Okay, so I'll give you one example. For example, for management purpose, you know that you can remotely connect to the CLI, okay, of your router. But in order to connect to that, you need an IP address. Okay, typically we can think of to use any of the interface because any of the interface on the router is already assigned IP address that we can use that to connect to the router. But it is not resilient in the case that if any of the interface that we depend on, okay, in order to connect to the router is down, then we lose access, okay, to the router. Okay, so if we specify a loopback interface, which is virtual, means it will always be, there's no physicality of it, so it will always be, in theory, up, right? So we can depend on it to be consistently up, right? So no matter, as long as one path is available to access to our router, no matter which path, right? We can access that router for management purpose by simply using the IP address that is applied to that virtual loopback interface. All right. Okay. So there's a lot of information. So just let me know if you need further clarification. All right. So in this example here, right, we are considering to use OSPF version 2. The routers have a starting configuration. The starting basic configuration, the configuration that you already know how to do, which is to assign IP address to each of the interface on the router. Remember that the IP address must be part of the host address for the network you selected for that particular network that is connected to that router, right? So in this example, currently we have not set the static routing or dynamic routing. Okay, all interfaces on the R1, R2, R3 routers except loopback one on R2. Okay, are within our SPF backbone area. So all of them are part of the core router area, except the loopback. Let me see, loopback one. Loopback one here, yeah, okay, is to represent the internet. Okay, so this is basically edge already. Yeah, whenever the interface is connecting to somewhere outside of our domain, yeah, our area means it's not part of the area already. So you can see loopback one for router 2 is the one that is pretending to be on the interface to go to internet. This is one way, another reason for using loopback. If you want to simulate something, then you can use or you can create loopback interface to act as that example interface, right? So probably we don't really have a connection to internet in usual term. If we connect to our ISP, right? Our ISP. But if not, let's say let's say we're working in our own lab, hardware lab, we want to pretend to link our routers to other not within our area, other routers. For example, going to internet, we can just specify or create one of the loopback interface. This here is loopback one, and that we can set aside as the pretend uh, link to. Okay. All right. The ISP router usually is used as gateway to the internet routing domain. That means that's not part of our worry about. We don't have to propagate to those areas. All right, let's look at router configuration mode for OSPF. Right, so OSPF version 2 is enabled in your router using this command, router OSPF and then process ID. This process ID represent a value between 1 to 65. Okay, so that means this is, I believe, 2 power 16, right? So 16 bit, 2 power 16 give you this value, the maximum value. So it's between 1 to that value, right? And the process ID value is selected by the network administrator. Okay, now this is very significant. This value when you select is locally significant. Locally means in your SPF area. Okay, so because it's significant, you cannot simply put in. If you decide to use that particular process OSPF process ID, then you will want to do the same for all other OSPF routers in your same area, right? So if you choose to use like here router OSPF 10, then other routers that participate in the same area, area 0, which is backbone area, will have the same OSPF process ID. Okay, remember this, yeah? All right, so that is process ID. Do not confuse with router ID. Router ID is used to um, provide a unique identifier for your router. Whereas here, process ID is refers to OSPF. Okay, so if your router uses the same OSPF process ID, means they're in the same area. So they will participate within this area in using OSPF, okay, to share information, routing information. Okay, so that's the difference here. This is OSPF process ID. The next part here is router ID. Okay, so router ID is a 32-bit value and it is represented as an IP version 4 address. Okay, it is used to uniquely, that's why it must be different for different router. One router might have one router ID, another router. So this is to uniquely identify that router. Okay, so it's very important to for the routers working in the same OSPF area to have different router ID so that they can be uniquely identified. Right, so you can see here every router requires a router ID to participate in that OSPF domain. So you must, that means after you set the OSPF process ID, you must set the router ID lah. Okay, it's a must, because if not, the router cannot be identified. Right, so there are two ways to configure the router ID. One is, of course, manually defined by the network administrator, or another way is automatically assigned by the router. Okay, so how is it used? Router ID is used by the router. We assume here all the routers under consideration is participating in OSPF. So the router ID is used when a router is participating to synchronize OSPF database. Right? So OSPF database means the selected router information that is that is following the OSPF protocols, right? What is being shared? If the routers are using OSPF to share information, right? That means those information exist within the OSPF database, right? So to participate, the router must have router ID and belong to the same OSPF domain. Okay, so router ID is used in when the routers are synchronizing their OSPF database, right? So during the exchange state, the router with the highest router ID will send their DBD packets first, get to share their OSPF database first. Secondly, in a multi-access network environment, okay, the router ID is used because we need to identify, right? So router ID is used as a way to participate in the election for the designated router, right? So why we need to do this is because we don't want to superfluously have a mesh network where every other router will exchange their OSPF database with every other router. Okay, if we are depending on the physical connectivity, physical link, yeah, potentially you have a full mesh network. That means router connect to this router, connect to this. Every other router is connected to every other router. That is a full mesh network topology. And imagine the amount of bandwidth used when they are all exchanging with each other. So in the multi-access LAN environment, okay, one of the router is elected to be the designated router. And this designated router is the one that is going to share the OSPF databases to all routers, right? That means the full version of the information will be shared from the DR, only from the DR to the other routers participating. Okay, so if a router is not uh, DR, then they will exchange minimal information with each other, probably just to say hello. Okay, send hello packets like this, very lightweight. So this results in lower bandwidth usage just for the OSPF process, right? If we have multi-access, if we don't have election for DR, we don't want a situation where bandwidth is being consumed by exchanging OSPF information. Rather, we want, okay, so we still want to share, but we designate one router as the DR, and then that DR will send the information to all other participating routers. Okay, and participating routers which not DR will still exchange info, but it's minimal. Okay, just to maybe hello packets and things like that. Yeah? All right. So and also maybe their link status lah, their interface status on is it online or offline, or what is their network address, or the link interface address. That's all. Okay. The more complete information will be shared by DR. Okay. So these two processes needs the use of, that means configuration of router ID for every router participating. Right, so router ID order of precedence. Okay, right, so Cisco routers that use a certain algorithm to derive the router ID. So three criteria is used, okay, and following this order preference. So first one is the most preferred. If this one does not produce any router ID, then we look at the second way. I mean, to break the deadlock, yeah. And then if this is not providing, then we look at the third method. So the first method is the router ID is explicitly configured using the OSPF router ID RID configuration command. This is recommended method. That means you design the network, you are the network administrator, you know how many routers, and then you basically identify each router. You can say, oh, this router I want to set as this router ID, this router. This manually. If you don't set it manually, then it's automatically assigned by the router itself. So the router, when it's assigning its own router ID, will choose, will look at all the loopback interface. Again, loopback interface. Why? Why not physical interface? Because loopback interface is considered as more stable. As long as the router is up, and as long as there's one path to the router, you can access loopback interface. Because it's virtual, right? This is software based. If you use any of the physical interface to to participate in the this automatically choosing, yeah, means if that router is down, or if someone changed the router interface, sorry, not router down, if that router interface is down, right, or if that router interface, physical interface, IP address is changed, then have to redo it again, right? Have to redo the router ID. So um, if you use loopback interface, it's always be up unless you manually go and shut it down, all right, or remove it. But if it's already up, you already configured loopback interface, it will always be up. So that means loopback interface is chosen by the router, okay, um, as to get the loopback interface IP version 4 address. So if you have more than one loopback interface, then the highest IP version 4 address for that between those loopback interface you configured will be chosen as the router ID, right? Only if there is no loopback interfaces, and or if there is, it's not up, or is it's not set with an IP address, then the router will drop down to 3. Okay, so the router will then choose the highest active, no shutdown part, means not down interface but up interface, active, IP version 4 address of any of its physical interfaces. So now if it doesn't have access to loopback, then it goes to physical interfaces. Of course, we just now described the downside of choosing physical interfaces address, okay, as the router ID, right? So knowing that loopback interface is quite important for step 2. Okay, anyone, either one of this, or any one of this, not either one, because there are 3. Okay, that the best way is to do number 1. Second best way is to do number 2. Third best way, or the least advised one, encouraged one, is number 3. Okay, but let's say you don't do number 1, you want to do number 2. So loopback interface. How will we configure a loopback interface on a router? So this is how, right? Just type interface loopback. You can put 0, 1, 2. Okay, interface loopback. Let's say this one is 1, interface loopback 1. Then as any other physical interface, this virtual interface, you specify the address. So IP address, and then preferably we can use 11111 or 22222. Okay, this is standard rule of thumb. Okay, but to make it as a host route, then means host route. You know, host route means in a physical or real way is that when a router is connected directly to a host. Okay, so that to make it easy to forward, right? You, instead of using you know, any network address, this is straight away host. Or remember the subnet mask that you put for this, right? For this address is 255.255.255.255. That will create this interface as a host route. Okay, so a 32-bit host route will not be advertised as a route to other OSPF routers. So this one will not, when the routers share the OSPF info with other routers, this interface will not be picked up as part of the shareable route. Okay, because it's a host route. Okay, right. So one thing you have to remember is that even if that interface is to be chosen as router ID, let's say this one, or SPF does not need to be enabled on that particular interface. It doesn't need to. You don't need to configure OSPF for this. Let's say this loopback interface, right? You don't need to configure OSPF on this loopback interface for that interface to IP address to be used as the router ID. Remember, this is you configure this loopback assuming that you want to use that for number two. Okay, of course, we don't have to, we still can configure this loopback address, but at the same time, we don't use that, we use manually configured. Okay, so, but if even if you manually configure, you can still manually choose this 11111 as your router ID. Okay. All right. Right. So let's look. This is for number two. Let's look at manually configuring or explicitly configuring a router ID. So we know the process OSPF process ID is different from router ID. So these two must be there for us to enable the OSPF. So you can see the command here. The first one is for OSPF process. So 10 is arbitrary. You can put in your own. But once you put a 10 here, let's say 10, you choose 10. All other router OSPF that want to participate in the OSPF in this area must also be set as 10, right? So router OSPF 10. Then you need to configure for this R1 router. What is R1 ID? So manually configuring is this way, router ID, then specify the address. If you specify manually, even if you don't specify loopback with that address, it still works, yeah? Okay, but of course, it's better just for me, for me personally, R1, oh, 1111. If I want to configure, so 111, so it's easy for me to remember. Okay, all right, so those are the two commands that and then you're done. So SPF it's now enabled, right? Okay, so if you want very quickly to see whether router ID has been configured, just type show IP protocols at the privilege mode. Show IP protocols, filter include router ID. Okay, just type exactly this. This filter is actually the pipe symbol on your keyboard above enter key, right? Shift and then press that pipe symbol. Then router ID will be shown to you. All right. To modify a router ID, okay, let's say you want to change to something else, maybe like this one, right? So let's say show IP protocols include router ID, it shows 10.10.11, right? So you want to change that, maybe it's a typo. Config terminal, go into global configuration, type router OSPF 10, because this router belongs to OSPF 10. So router OSPF 10 first, then it says config router, right? Then type the correct one, right? Router ID 1111, and then clear the IP. That means you reset the OSPF database to indicate there's a change in the router ID. So type clear IP OSPF process, and then follow reset all OSPF process. Yes. Then when you type show IP protocols include router ID again, then it shows the new updated router ID that you modify here. Okay, please remember you need to specify that. Okay, so here it says clearing the OSPF process is the preferred method to reset the router ID. So don't forget, after changing this, you have to type this command, clear IP OSPF process. All right, so um, any question for the moment?
No.
No, 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 Farah?
No.
No, Kelvin? No, huh? Okay, okay. So good, right? So we proceed to the next section, which is point-to-point OSPF network. Remember, we have two types, point-to-point and multi-access. Point-to-point simply means one router connects, in general, maybe usually is a serial cable. One router connects to another router, point-to-point. Okay, okay, let's have a look. All right, so for point-to-point network, you can specify the interface that is participating or is belong to the point-to-point network by configuring the network command, right? And then you can also configure the OSPF directly on the interface with the IP or SPF command. So let's look at the syntax. So again, OSPF router, sorry, that command, okay, I forgot already. What is it? That one, router OSPF 10, right? To enter into config router, okay. If you're in privilege mode, configure terminal will bring you to the global config, right? Under there, type router OSPF 10, you go into config router, right? So to get into this, then once you're inside there, then the network command, and then the options here, yeah, options. So network address, the wildcard mask. Now wildcard mask is very similar. In fact, it's opposite to subnet mask. Okay, wildcard is a filter. Basically, it's a filter. So depending on the value you put for wildcard mask, then you will filter what addresses, network address are being forwarded or being shared towards this particular interface. All right. So it basically works for wildcard. Remember that you can get the wildcard by getting the 255, 255, 255, 255, and subtracting the subnet mask, you will get the wildcard mask. All right. That's how you get the wildcard mask. If you're not sure wildcard mask, what is it? Then this network address, what is the network address subnet mask? Then you subtract that subnet mask for that network address from 255, 255, 255, 255, which is the maximum, right? And then the value you get when you do this is in binary, yeah? And then you get the wildcard mask. Okay, and then area, okay, type area, and then the area ID, the 10, right? Because we are working on OSPF, example is 10. All right. All right. So basically, the wildcard mask, if you look at it in binary, okay, you will see that there are two types of values, zeros and one, right? So what does it mean when we are saying filter or mask, okay? Right? So what do we allow, what we don't allow? So when you look at the wildcard mask in terms of binary value, the zero part of the wildcard mask have to match the same position in the IP address. So if an IP address means if when you also convert IP address to binary, right? Only the ones that match in the same position, okay, must be exactly uh, matched lah. If you have a one, means is acceptable for any values to go through the filter, right? Okay, so let's go back to here, right? So you can see the network address wildcard mask syntax is used to enable OSPF on the interface, right? So any interface on a router that match this part of the command are enabled to send and receive OSPF packets. So that means when you put the wildcard is a filter. So when you're processing, when you're processing to basically share information, okay, routing information, only those matching network address wildcard masks will be forwarded onto the interface that match this wildcard. Right. So again, area ID, refers to your OSPF area. So just now our example is 10, so we put 10, right? Right. Says here, although any area ID can be used, it is good practice to use an area ID of 0 with single area OSPF version 2, right? It says if you do this, this convention makes it easier. Later, if your network is changed from point to point to uh, single area to not network, single area OSPF to multi-area OSPF, then by starting with area ID of 0, it will make it easier for you. Because if you're multi-area, simply means that your area, you have more than one area ID already. So starting with 0, then you can just proceed 1, 2, 3, 4. If you give it 5, then you have to work backward of 0, 1, 2, 3, and then skip something like that. So it's easier to start with 0 for single area. If you change to multi-area, now you have more OSPF area, then you can simply increase assignment, right? Right, so here is the wildcard mask I was talking about. You can see that the maximum value is all ones, right? 255, 255. You just simply subtract the subnet mask for the network address or the IP address of, the IP address of that particular interface, right? And then you get the wildcard mask, right? So you can see here, easy method for calculating a wildcard mask is to subtract the network subnet mask from 255, 255, 255, 255, right? And then you get the wildcard mask. In fact, you have to convert first lah. You have to convert first. It's easier to see, but you can work on decimal also, right? Right. So configuring your OSPF using the network command. So this is a different way of configuring network. Here you are working with the, let's see here, network and then network address and then wildcard mask and then area ID, right? So here's another way. And in this way, we allow the subnet mask to be entered instead of wildcard. So if you enter network address and subnet mask instead of wildcard, the router converts it for you. See, iOS then converts subnet mask to wildcard mask format for you, right? The first one is that you calculate yourself, you put in yourself the wildcard. Here, you put in the subnet instead, and then it will be configured, it will be changed for you, right? So, but it depends on iOS version. If you have older, maybe it will not do it for you. If you have a newer version, then it will do it for you, right? Another alternative is you put exact interface IP version 4 address. Again, if you do it this way, it's the iOS that's doing it, doing the calculation for you. So because you can extract from the interface IP version 4 address, actually the router can extract, the iOS can extract by doing ending, right, the network address, right? In this way, you put exact interface IP version 4 address using quad 0 wildcard mask. So example, entering this network address 10115 with quad 0 wildcard mask, area 0 on R1, tells the router to enable this interface, which is gigabit Ethernet 000 for routing process to allow routing info to pass through the interface, right? So advantage of this is, again, wildcard mask calculation is not necessary. Okay, so here we use area 0 for all, just note, okay, because single area or SPF. Okay, so whichever one you prefer. I believe this one is the easiest one, right? Now, remember, for any of the interface you didn't specify, then it will not be participating, right? for any interface on the router that you want it to participate in OSPF, you have to do this. You have three interface on the router. On all three must participate. Then you have to then this lah, like this, three interfaces. Okay, and they all must have area 0 because they're single area. Right. Next, configure OSPF using IP OSPF command. Right. This is to configure OSPF directly on the interface. Here, you are configuring it under config router. See, access by typing router OSPF10 area 0. So here you go directly to the specific interface. So typing interface and the interface itself will bring you to config interface, right? And then you specify IP OSPF10 area 0, IP which area it participated in and which OSPF it belongs to, right? Okay, so either this or this. See here, no means you are removing this configuration. Instead, you want to do interface by interface basis, right? That's why we put no first. We want to use directly on the interface, right? So we remove the global router configuration. So no, just put no in front will remove that entry. No. Then, of course, you still want, right? But you want to use IP OSPF command. For this one, you have to go to each individual interface that want to participate in and specify it. IP OSPF10 area 0 IP, right? So in this case, you either use interface then type, or the first method, which is you don't need to specify the interface, but you specify the address of that interface instead. So whichever way you want to use is good, this way or this way. Okay. All right. So passive interface, by default, OSPF message are forwarded out all OSPF enabled interface. So let's say here, all this interface you already specified. So that's going by OSPF enable interfaces. So OSPF messages will be forwarded through all the interface that's been OSPF enabled, right? However, okay, these messages only need to be sent out interfaces that are connecting to other OSPF enabled routers. This makes sense. It's logical, right? If the other router is not OSPF capable or you don't want it to participate, then there's no need to send out through that, right? See, this is an example why lah. Sending out unneeded message on a LAN would affect network in 3 ways. Inefficient use of bandwidth because it's superfluous. You know it's not going to be used, but you still send it anyway, right? So unnecessary message will be sent, which not being used. Inefficient use of resources. When you send something, all devices are obliged to see what is that message. Only when they check the message or process the message, then they know whether it's meant for them or not. Okay, and if they do, in terms of OSPF, if that router is not participating in OSPF, but that router needs to read that message, and then the router at the end still discard the message because it's no use to the router. So that means your resource already used in the sense the processor inside the router already checking up what is that message, at the end still not using it and discard. So in the first place, why send the message to that router in the first place? So we want to prevent inefficient use of resources. Increase security risk. If you specify OSPF but did not configure the security configuration, the OSPF messages can be intercepted by any packet sniffing software. So let's say you met in the middle, you somehow managed to go and get in between the two routers communication, then you can just uh, because you can just tap into the wire, right, physically, and then you can intercept these messages, including OSPF. So um, the thing is, not only you can intercept and read, you can also introduce, right? So what if the attacker introduce routing updates, right? And then it will be sent to the router participating, and then the router updates its routing table. And then with the false matrix means you can then have in your hand as an attacker a way to influence the the path, choosing the path. Remember, the OSPF is one of the algorithm not only to share routing table, the routing table affects how the router, if there's multiple path, choose the correct path. Okay, and of course, shortest path is means in terms of cost is the least cost lah. That means it's fastest way to send. But if you influence, if you, as an attacker, you can influence the routing table. You can then redirect, change the cost measurement, and redirect. Uh, routing, forwarding of packets along different routes instead, right? So increase security risk. So passive interface means it doesn't send out any OSPF info. So that means when connected to routers that does not participate, so we just block basically passive, right? So use passive interface router config. Again, go to config router OSPF 10, passive interface loopback 0. So loopback 0 is one of the there is it's a virtual, and it doesn't go anywhere actually, right? So loopback 0, we don't want to unnecessarily send something like OSPF information to the loopback 0 because it doesn't go anywhere. This is one example, right? So we want to set the loopback 0 interface as passive, right? And by typing show IP protocols, you can see as part of the info that is shown as passive interfaces, it will list out those passive interfaces, loopback 0, right? So what it means passive interface is prevent transmission of routing message, but still allow the network to be advertised to other routers. So that means this interface here belong to a network for that particular loopback interface. So other routers still aware this network exists. Okay, the network as part of the loopback 0 interface on the router. So other routers still aware, but the router routing messages will not be shared into this interface because there is no router at the end. It's a loopback interface. Okay. Okay. All right. OSPF point-to-point network. By default, remember for multi-access network, we need a DR and BDR. So by default, Cisco router elects DR and BDR. Okay, so it's basically it's turned on by default, right? So you can verify by typing show IP OSPF. You type show IP OSPF and the interface, and it shows you um, uh, whether there's a designated router, BDR, backup designated router. Now for point-to-point, okay, there is no other routers. So the possibility of creating a full mesh network or a partial mesh network doesn't exist. Remember, we just don't want to have too many sharing of router information, duplication between routers to routers, routers to routers, routers. In a multi-access network, we only want the DR to send routing, routing information. So in a case where point to point, because we don't need, we have, because it's by default it's turned on, we have to disable it, right? You can see here the DR-BDR election process is not necessary, as there can only be 2 routers on the point-to-point network, right? Okay, so to disable multi-access network with BR-DR election, we specify for that particular interface going to the other router, we specify as IP or SPF network point-to-point. So then there is no DR and BDR packets being shared. Okay, there is no election process going on because it's point-to-point. So this will disable it for that particular interface. Because for that particular interface, it is a point-to-point. Okay. Right. Loopbacks and point-to-point network. Right. So loopbacks provide additional interface for a variety of purposes. One is provide router ID. One is to pretend to connect um, to ISP. Maybe imagine that it's connected to the cloud, or you can use it as a as an IP address for you to do management. Okay, to link to that router to do management, to connect via telnet or SSH. Okay, many variety of purpose you can create loopbacks, right? So by default, loopback interface are advertised as /32 host routes. Okay, how host route, not network routes, host routes. So to simulate a real LAN, the loopback interface can be configured as a point-to-point network to advertise the full network. Okay, right. So what will the router 2 sees if router 1 advertised the loopback interface as is? Show IP route. You go to route 2 to look at the routing table. Show IP route include 10.10.1. So it sees there's this 10.10.1.1.32. So it's host routes, right? Okay. Configuration chain at R1. If you make it as a point-to-point, you pretend that it's not you have an endpoint in that particular device is connected to another interface. You have to set this interface loopback 0 IP or SPF network point-to-point. Simply means it now becomes a network rather than host routes. So the change when you check again, right, at R2, you see that it's now /24 rather than /32. Is it okay for this part? Press 1 if you're okay with this part. Okay, right. So doing this means, oh, okay, this loopback actually pretend lah, right? Because it's a virtual interface. It's actually a point-to-point network, right? Since it becomes a point-to-point network, that means it is a network there. So /24, different from previously it was host routes, /32. Okay, right. Okay, packet tracer will consider in our practical. All right, so this is the second part. Okay, just now we'll consider point-to-point or SPF networks. Now we look at multi-access OSPF network. So let's look at the diagram, what I mean by multi-access. So point-to-point is this. Router to router, serial cable, point-to-point, from one point to one point. Multi-access is this, where we have a switch to connect. Just one example topology. It could be a different kind of topology, but this is the simplest we can create to highlight what we mean. Okay, so you can see here R2, R1, R3, R4 all connected via switch. So this is multi-access OSPF network. So if R2 for point-to-point wants to share routing information, there's no other place but to share point-to-point with the other router. The other router also the same, share to R2. But here, R2 will share with R1, R4, R3. R3 will share with R2, R1, R4. R4 will share with, okay, That's what I mean by fully connected. So that means you will have a lot of broadcast information. This one will broadcast, this one will broadcast full database, full routing, full OSPF information. This one will broadcast, this one will broadcast. So you'll see that the network performance here will be laggy because of latency introduced by additional broadcast messages, right? So for multi-access OSPF network, we specify the DR and BDR so that only one router controls the distribution of LSAs, right? So what is LSAs? So LSA is again acronym. So again, we just want to say that computer science a lot of acronym, including networking, right? So link state advertisement. LSA is a link state advertisement, right? So basically, it's sharing information about its interface and the address for its interface to other network. Remember that for the interface represent the network that a router is connected to, right? So we already said that uh, on a specific router only know about its directly connected network, but it doesn't know remote. So other routers, when they share their link state, means they are sharing the network information that is directly connected to that router to us, which we don't have any idea about because it's one hop away, right? And the information includes the link state, which is up or down, and what address is tied to it, what network address tied to it, right? Okay, right? So in a multi-access OSPF network, one router becomes the DR, which is control the distribution of LSA. This router is elected for this role. Again, there's an election. Sometimes we call this autonomous area because once you configure, it should be able to work on its own without you needing to do anything furthermore, right? So one of the automatic issue is that this DR is elected, and then the second BDR also elected. The second highest router will be elected as the BDR, just in case the DR fails or something happened to it, and the BDR takes over the job. Right? So if you want to influence the router that becomes the elected router, then you need to do proper configuration. So knowing how the router is elected is actually helpful to you as a network administrator to make sure if you want to bias the election of which router should be elected. Right? You can see here OSPF designated router or DR. In multi-access networks, OSPF will perform election to elect the router that is DR and BDR. Okay, two different routers. One router become DR, another secondary router, okay, through the election process become BDR. All right. So DR, once the router becomes DR, the DR designated router is responsible to collect and distribute RSA that it sends and receives. Okay, and to do that, the DR use multicast IP version 4 address 224.0.0.5. And in fact, all the OSPF routers belonging to the same OSPF area, okay, will be subscribed to this multicast address, right? So the BDR is also elected during the election process because we want it as a backup. If the DR, the main router fails, the DR fails, then BDR will take over the job, right? So BDR is working in the background, patiently listening, passively, not doing anything, just collecting all the information, right? And still maintain a relationship with all the routers. Maintain relationship simply means that If the other router send hello package, then packet, then BDR response lah, right? Because so the others are aware that the BDR is there, right? So if DR stop producing hello, that means something wrong. BDR will notice this, that, and it will promote itself to assume the role of DR, and then it will take on the responsibility of a DR, right? All other routers that is not DR or BDR is usually named as DR other. Okay, DR other means a router that is not DR or BDR. So for themselves, they use another multi-access address 224.0.0.6 to send OSPF packets to the DR and BDR. Okay, means they will send not to each other but only to DR and BDR. All right, DR BDR becomes passive listener. DR will send full info to BDR and other DR others. Okay, and then DR others will send info to DR and BDR, because BDR is a backup, right? So they always consistently have a copy lah, right? But then DR other do not send to each other. So that's why the only DR and BDR listens to this. The others do not listen to this because they do not send to each other. They only send to DR and BDR. In that way, we reduce the amount of bandwidth used. If we don't have DR and BDR, it means they will send to each other, right? And then make up a lot of information inside, take up a lot of bandwidth to send those information in the network. All right?
So
Yes.
if the PDR fails, what happened?
I think when the BDR becomes DR, there's an election to elect the next BDR.
No. Okay.
All right. So it will keep on. I'm not sure what happened when you are left with only one router. I haven't found out yet. I will try to find out what happens if in the multi-access router. I think that's a catastrophic network failure. If all routers fail, only one, and then you have DR, and then there's no one to take up the BDR slot. But then if you only one left, I don't think you're in a position to share anything anyway. Then that is a catastrophic network failure. So somebody have to go and fix something. Okay, no. But if in the sense that it's very rare that a router should fail, but we just prepare in case, right? So to answer your question, if a DR fails, BDR takes over, another election will basically elect the next BDR. Okay, this is my assumption. We'll find out later. I think it's further down the slides. All right, so next, this one, this is OSPF, a typo there. I think I will remember to correct. Let me just correct this very quickly. Okay. Okay. OSPF multi-access reference topology. This is the one that we are going to base our further configuration example on. So here you can see it's multi-access because router can connect to R1 to R3 and so forth using this switch here. And this one connects to this network, 172.16.2, and I don't see that it's I don't think it's a loopback. All right, never mind, there's no loopback. Okay, but let's look at this what here content. In the multi-access topology shown in this figure, there are three routers interconnected over a common Ethernet multi-access network, and this is the common network. Remember, this is an let me just highlight. Okay, so this It's a single network, right? And this is the network address for it. Okay, that's what it means. Okay, common Internet multi-access network. And this is Ethernet multi-access. You can also have token ring multi-access. Okay, right. So because the routers are connected over a common multi-access network, OSPF has automatically elected a DR and BDR. R3 has been elected as the DR because its router ID is 3333, which is the highest in the network. So you can see, how do we get the router ID? Okay, the first method is we assign it. So that's why as a system administrator or network administrator, you can decide which one becomes the DR, right? So we highest router ID is 333, so 333 becomes the DR. So which one becomes BDR? Well, the second highest, which is this one. Okay.
Okay.
All right. So here we want to verify OSPF router roles. Okay. So to do that, you type show IP OSPF interface command, which is actually shown here. You have show IP OSPF interface, and then the interface you want to look at. Right. The output generated by R1 confirms that R1 is not the DR or BDR. You can see here such state DR other. Okay, priority 1. Okay, the DR is R3. See, designated router is known by the R1 as the router 3, which is 3333, highest router ID, right? And BDR is 2222. Okay, router ID 2222, right? So R1 has two adjacency. Adjacencies means router connected to it. Okay, one is the BDR itself, and one is the DR. So you can see adjacency with it is adjacent. This router one is adjacent to a neighbor router 2222 and 3333, which is designated router, right? So it's that's why just now it says security concern. This kind of information, if it's shared between routers, you can basically build a topology. You know the topology already by looking at this information, and knowing topology of a network is a first step for the attacker to. Because if physical, you're not very sure. You see, physically the cabling is set up not in the way that the topology diagram actually show, right? um Sorry, the logical topology, right? Physical, maybe you can see lah, it's superimposed upon your building layout, your room layout, something like that. But in real life, you can tell. So but this one is showing you logical topology already. So you if you want to be an attacker, first thing you need to do is to understand the network. What exists in the network, how is it configured. So this one, by looking at this info, I straight away know adjacent. This router one is adjacent to neighbor. This one, which is a BDR and DVDR. So you if you have this information, you can basically manipulate by using the cost metric for OSPF. You can then redirect, uh, you know, packets, right? So you go to R2. Just now we were at R1, right? R1. So you go to R2 and you type the show IP OSPF interface, gigabit Ethernet. You can see that this is R2 with router ID 2222. R2 is the BDR, right? With with a default priority of 1. Okay, state BDR. Just now state DR other. Now it's state BDR. Okay, and the DR designated router is 333 identified already. Okay, via this interface address, and also BDR interface address and its adjacency with neighbor. Okay, neighbor. This is also good for troubleshooting. Once if you see this info and it matches the configuration uh, that you need to create for your network, then you can see it's done properly. Right. So now we go to the third router, R3. You can see state is DR. Right. And other information remains the same, but related to R3. Okay. All right. All right. So verifying DR, BDR adjacency. So show IP, OSPF neighbor, DR other, DR, BDR, and DR other. All this information just now we've seen is a way for us to verify adjacency of DR, BDR to a particular router. No matter what is the router, whether it's the router is BDR, BDR, but you can still see it's adjacent to which one. Remember the multi-access, they share the common Ethernet network, right? Right. So another command that you can use, show IP or SPF neighbor, right? So you are R2 means your router ID is 2222. So you can see neighbor ID is 1111 is the full DR other. Then 333 is the full DR other. Another way to see. All right, so let's look at the election process for DR and BDR. Right, so these are the criteria for the election in sequential order. So the routers in the network elect the router with the highest interface priority as the DR. The router with the second highest interface priority becomes the BDR. So the priority can be configured again. This is manually configured by you, the network administrator, between 0 to 255. If the interface priority value is set to 0, that means you are specifying that interface cannot be elected as DR or BDR, right? The default priority of multi-access broadcast interface is 1. If you set to 0 means you don't want it to participate. If the interface priorities are equal, then the router with the highest router ID is elected, becoming the DR. The router with the second highest router ID is BDR. See, if the default priority is 1, you basically don't want to use, you let it be 1. So all the priority will be 1. You basically relegate the election to number 2 process. You get what I mean? So if you don't want to set default priority of interface, so you ignore this step. So being equal means they look at router ID. Okay? So when you look at router ID, you left all the interface priority with default at 1, means it will be equal, then it will step to number 2. So at number 2, then you can set your router ID appropriately. The highest router ID will be selected as DR. Okay, this is another trick or another way for you to configure the DR VDR as a network administrator. We normally do not want to go to each interface to set the priority. So we ignore the number 1 election, means it will go to step 2. So here is the one that we manipulate as the network administrator. We just simply set the highest router ID for the router that we want to win as the DR, and then second highest to the second backup router. Okay. Right, DR failure and recovery. So this is when the main router, the DR router, the designated router fails, right? If it fails, OSPF process on the DR fails or it stopped, that means no more hello, no more updates, whatever, right? Then BDR is automatically promoted to DR, right? Okay, so if another another router which is not DR or BDR with a higher priority or router ID is added to the network after an election, right? However, That means even if you add another router with higher priority or router ID supposed to be better than DR or BDR, we still do DR and BDR, and BDR promoted to DR still promoted even though maybe the new added, because this was done on the previous election. Okay, so but after BDR is promoted to DR, a new BDR election occurs. Remember my answer to Noel just now. Then to elect the new BDR, then only the DR other with the highest priority router ID is elected as the new BDR. Okay, this is what happens during DR failure and recovery. Again, it doesn't say what happens if you have left, if you have catastrophic network failure. Meaning to say you only have one left DR, no BDR. No election can happen, I guess, right? All right, so IP OSPF priority command. This is the one that for step number 1 that you can specify the IP OSPF priority, right? And by default it's 1, isn't it? Right? Uh, if you set it to 0, that simply means you as a network administrator, you don't want that router to participate in the election, right? You can see a value of 0 does not, because you set it to 0, right? Okay. So basically just leave it as default lah, and then you can use the router ID for the election. Excuse me. So how to configure, if you want to configure OSPF priority? Just go to the interface from global configuration, type interface and that particular interface. You go into configuration for that particular interface. Here, gigabit 0. Then you type IP OSPF priority 255, right? And then after that, clear IP OSPF process to reset, right? To reset, and then this new value will be taken into account. Right? So far, okay? Any question?
No.
Noel and Kelvin?
No.
No, huh? Okay, so far it's straightforward, huh? Okay, so let's look at modifying single area OSPF. So far we've done configuration on single area OSPF. So now let's see how do we modify, right? So that means once you have the OSPF, this is the thing that we don't want attacker to do. But we also want to do this, but because we want to we want to see the path, because OSPF follows short path algorithm, shortest path algorithm. So we need to understand what is meant by shortest path. Basically, for a Cisco OSPF, it's based on cost metric. Okay, so routing protocol use a metric. This in general, there must be a metric for the routing protocol to refer to determine best path, right? So OSPF use cost as a metric. A lower cost means better path. Okay, higher cost means worse path. So it will always try to find a path that has the lowest cost among all candidate path. Okay, so Cisco cost of an interface is inversely proportional to the bandwidth of the interface. What does it mean? Means higher bandwidth, because high inverse to lower cost. The higher the bandwidth, the lower the cost. So that's why we call it inversely proportional. It's the reverse lah, right? Inversely proportional means as the bandwidth go up, it's proportion, right? The cost go down, right? So the formula used to calculate the OSPF cost is the reference bandwidth, because not the real bandwidth, the theoretical bandwidth, the reference bandwidth, divided by the interface bandwidth, right? The default reference bandwidth is 10 to the power 8. Therefore, formula is, imagine lah, let's say 100 million bits per second divided by interface bandwidth in BPS as well. Because OSPF cost value must be an integer, it cannot be real numbers with a decimal value. I mean, fast Ethernet, gigabit Ethernet, and 10 gigabit Ethernet interface share the same cost. To correct this situation, because if you try to see, it's actually when you try to divide, it's like you're getting a real value, right, with decimal. Then if we round it up, we always get zero, which I think so like you can try out. It will always be zero. So we don't want that, right? Because then we cannot differentiate between fast Ethernet, gigabit, or 10 gigabit Ethernet interface. We want to assign different costs for different speed, but we want this inversely proportional, right? So we use this formula, but this formula result in floating point, which is not ideal for us, right? So you can adjust the reference bandwidth, the auto cost reference bandwidth command on each OSPF router. Manually set the OSPF cost value with the IP OSPF cost command on necessary interfaces. Let's have a look first. What do we mean? So you can see by using the formula for each of the interface type, you get 0.01, 0.1, 1, and then rounding it up, we get the same cost except for Ethernet lah, but we cannot differentiate between fast Ethernet, gigabit, and 10 gigabit Ethernet. They all end up becoming one, right? And that's not ideal for us if we want to use this cost metric based on inverse bandwidth, right? So this is what we are talking about in here, right? In here, the result here is not, it's not good for a metric. So what can we do, right? The cost value must be an integer, so that's why we round up decimal value. But then it's, you know, it's not what we wanted. If something less than an integer is calculated, OSPF rounds up to the nearest integer. Therefore, the OSPF cost assigned to the gigabit Ethernet interface is 1, right? So all interfaces faster than this one is 1, but this also 1, right? That's what I mean. For this, all interfaces pays faster than fast Ethernet will have the same cost value of 1 as a fast Ethernet interface. To assist OSPF in making the correct path determination, the reference bandwidth must be changed to a high value to accommodate network with link faster than 100 megabits per second. So from faster than this means here and here should not be 1 and 1 also. That's what it means, yeah? Right. So adjusting the reference bandwidth. Changing the reference bandwidth does not actually affect bandwidth. Of course, we are only manipulating the metric, the way we calculate based on the bandwidth. We want to calculate the cost because OSPF based on cost. But the cost right now is not very useful, right? But so we want to change the reference bandwidth so that we are able to provide a better cost. Okay, so the lower, remember cost here, it says lower cost indicate a better path. Better path here means faster network, right? So yes, 111 is better, but here we cannot differentiate already. Of course, this one should be better than this should be better than this will be better than this. Here and here, okay, but here, not okay lah, because cannot differentiate, right? Right. So to adjust the reference bandwidth, use the auto cost reference bandwidth megabits per second router configuration command. This command must be configured on every router in your OSPF domain. Notice in the command that value is expressed in megabits per second. Therefore, to adjust the cost of gigabit Ethernet, you have to convert lah. So auto cost reference bandwidth 1000 megabits per second means 1000 megabits per second is equivalent to 1 gigabit Ethernet. For 10 gigabit to 10 times. 10 times 1000 is 10,000 here. Right? So you basically increase the what so that it enlarges it. To return to the default reference bandwidth, use the auto cost reference with 100. Okay. Right. So this is one way. Another option is to change the cost on one specific interface, the particular interface with that bandwidth using the IP OSPF cost command. So cost and what is the cost, right? So you can assign manually the cost rather than calculating based on the bandwidth. Whichever method you use, it's important to apply the configuration to all routers in your OSPF routing domain, so that they're all basically equal way to determine costs. Okay, because if you're not consistent, then your routing path is wrong. Okay. All right. So the table here shows the OSPF cost if the reference bandwidth is adjusted to accommodate faster Ethernet links. Like here, example, 10 gigabit Ethernet links. Right. So you need to adjust it anytime your links are faster than fast Ethernet. Right? So use the show IP OSPF interface command to verify the current OSPF version 2 cost assigned. So you can see now, once you adjusted, right, there are now 1,110 and 1. Okay, you basically just change the scale. Okay, you're basically applying scaling so that it shows the differences in the bandwidth better. All right. So that means if you have anything faster than Ethernet, like this, you have to specify. You have to do this already. Or you can straight away use this command and place your own costs inside. All right. Okay. So once we have this, then it's easier for us for the OSPF basically to uh, to to find out which is the better path. Right. So how to calculate the cost of the OSPF route that is going to be taken is the accumulated value of the cost from one router to destination network. Assuming the auto cost reference bandwidth 10,000 that we used earlier on, the cost of the links between each router is now 10. So 10, 10, 10. Here's fast Ethernet 1, 1. So we have gigabit. Gigabit is 10, right? Only if you have 10 gigabit, then we have 1. So um, and we have here cost one means that is 10 gigabits Ethernet. Yeah. But that is actually fake because it's, excuse me, we drink water first. Because it's actually local to the router, but this is virtual, so that's why we put it as high. So it's cost one, right? But the rest, which is gigabit, is 10, correspond to this. Right? Loopback interface, because it's actually not existing as real network, it's actually a virtual network or virtual host route is set as 1. Okay, high speed lah. Right, so calculating the cost for each router to reach each network. For example, for R1 to reach 10.10.2, so R1 is here, to reach 10.10.20 here is 11. Why? 10 plus 1, 11. So this cost is 11. So if we go this way, accumulate 10 plus 10 plus 1, so 21. So obviously, based on that, okay, lower the cost. That's the path that's chosen. So this one is faster, right? Lower cost. 10 plus 1 is 11 rather than here 20 plus 1 is 21. So this route will be chosen, right? So you can verify this with the show IP route command 11. Okay, that's the route that is chosen. So its cost is 11. for 10.10.2. It will not show this path in the routing table because this path is not considered a good path to go here when you have a better path here. So the path here is the one that is going to be entered into the routing table. So when you are doing the routing decision, this path is the one selected lah, because this one not considered. Okay, because this is the better path. All right, so you can see when you show IP route, and then it shows this is the route that is going to take, because we forward the packet through. Right? So just now this one is your own cost. This is not depending. You can then disregard the speed of your connectivity. Right? Here you want to influence. Okay. I'm not sure whether this is good, but you can do it. So if you want to bypass the other path, you want to prefer, even if it's a longer path, but you want to just set the cost, right, for that interface, and then the calculation will base on that value that you manually set for that interface. So basically you can influence the path, right? So the red color means you have set your own value, right? So basically here 10 plus 10 20, here 30 plus 10 40 plus 10 50. Okay, right? Test failover to backup route. What happens if the link between R1 and R2 goes down? So R1 is here, R2, this one down. You can simulate that by shutting down the gigabit Ethernet 00. So this one, right? Shut it down, then there's no route there, right? So, and verify whether the routing table is updated to use R3 as the next hop. Even though it is cost, but this is the only path now. So this one should be enabled in the routing table because this one is down. So even though this is a better route, but it's down, it's not available. So you can check whether this alternate path will be used, right? So notice the R1, if you type show IP route OSPF begin 10, right? Begin 10 means anything with 10 lah in front, right? So you can see that the path to 10.10.2 here is via the 50. So calculate 30, 40, 50, right? Is using R3 as the next hop rather than R2 because you shut down here, right? Is it okay so far? Just take a short time to ask your feedback. Okay, huh? So far okay,
Okay.
huh? Kevin okay. All right. Okay, Farrell also okay. Noel okay. Okay also. All right, so we continue, yeah. Right, so the next slide is to test failover to backup route. Oh, sorry, this one already done. Let's go to the next one, is hello packet interval. Right, so hello packets are transmitted to all multicast to all the routers subscribed to the multicast address 224005. Right, so means all OSPF routers every 10 seconds. This is default timer value. This is to just to let the routers participating know whether the routers that is participating in the OSPF are all alive, okay, not down, okay, reachable, okay, except interface that was set as passive interface. Remember just now the command, this command we typed um, for the loopback interface because, well, the loopback is actually virtual, so we set it passive. So hello will not be sent through passive interface, right? So because it's only sent out every 10 seconds, the between period between transmission of hello packets is called the dead interval, right? So the moment it reached 10 seconds, it still receive, oh, okay, reset back the timer, right? So let's say it miss a hello packet, then wait. Okay, because once you're expecting after 10 seconds, you expect the next hello. You don't receive it, then you wait. Once a certain interval elapse, then that router still don't have a hello packet from that particular router, another particular router, then it will deem that particular router as down, right? So, and then it will remove that neighbor from its link state database, right? The router floods the link state database with information about down neighbor of all OSPF enabled interface, right? This call use a default of 4 times the hello interval. Okay, that means the interval for that interval is 4 times the hello interval. So after, if let's say your hello interval is 10 seconds, 4 times like 40 seconds. So after 40 seconds, if you don't receive any hello, considered as dead. That means considered as down, right? Then you are removed from consideration. Okay. All right. So how to know whether what is configured for your router in terms of hello and dead intervals? Right? So these hello and dead intervals are can be configured per interface. Yeah. The intervals for the hello and dead between one router and another router, which means they are adjacent to each other, must match, or else uh, they're not considered as a neighbor. Right? So you type show IP OSPF interface gigabit 0000. Then under here, timer intervals configured, hello is 10 seconds, dead is 40 seconds. By default, the Cisco default is this, right? So if you see that this is set as default and the other R2 is set as at this default as well, by if you don't change any of this value, so there will always be adjacent, right? Neighbor adjacency will always occur. It's only when you go and change something, then you don't repeat it on the other adjacent router, then uh, you have a problem. That means if you change this, you must change the, the router adjacent to this interface. Okay, right. Okay. Use the show IP OSPF neighbor command to see date time counting down from 40 seconds. By default, this value is refreshed every 10 seconds whenever your router receives a hello. Okay. It will start. It will continue counting down when you don't receive hello for 40 seconds. It will then remove you from the LSAB database. I mean, you as in the other router. But every time you receive hello, after every 10 seconds, it will reset the timer. Okay. All right. So how, if we want to change, how do we do that? Right? Why? But first of all, why do we want to change? If we consider the intervals too long, if you want it to be faster, you want to detect there's a problem faster than 10-second and 40-second dead interval, right? Because here you can see it may be desirable for you to change the timers so that your routers detect network failure in less time. So let's say 10 to change to 5, for example. So in 5 seconds, they must receive failure interval, or else they start counting down, and you can even change the dead interval to less time than 40 seconds, right? So that means your network will be aware of down. That means it will reconfigure faster, okay, if you detect any network failure, right? Okay, there's a disadvantage to this because your hello interval will be sent more frequently, means increase the traffic lah. Okay, and so you as a network administrator, you have to decide whether it's better for you to get quick convergence. Quick convergence means the re-election is happening faster, right? The updates all happening faster for the OSPF, right? In response to network failure, or it's better means it's more important to you than the extra traffic. Okay, when we shorten the hello intervals, right? Because by default it's every 10 seconds, right? Now every, let's say 5 seconds, you move it to 5 seconds, you lower it down to 5 seconds. So every 5 seconds, hello packets will be sent from the routers to each other, right? Right. So to modify that, just into the particular interface. Remember, we can specify it per interface. But if you set it in one interface for this router, the adjacent neighbor router, you must set the same interval and hello and dead intervals. Yeah. So use IP or SPF hello interval seconds. You can, well, basically you can shorten it or you can elongate it. Means more than 10 seconds, but I don't know why you want to set more, right? Uh, and then same similar with that interval, just change error interval to that interval, and then this how many seconds you consider, right? So this example is shown here. Go to that interface. Here we reduce by 5 seconds, from 10 seconds to 5 seconds. That interval is reduced from 40 half it to 20 seconds, right? And when you show IP or SPF neighbor again, you can see the elapsed time and then the reset time. Okay. All right. So far, okay?
Okay.
Okay.
Okay. All right. So again, I said this chapter got a lot of info. They're not very hard, but a lot of info that maybe later on you need to go through back again. Maybe you can use your NetAcad account to go through the notes, more detailed notes online. Go back through again. All right. Right. So this section talks about default route propagation. So that's the one of the information that we want to propagate, right? Default static route. Okay, how do you do that in OSPF version 2, right? So the edge router must be configured with the following: a default static route using IP route. Okay, this one always the static, default static route, right? Then default information originate router configuration command. This is very specific command, right? If you type this in R2, then this command in R2, okay, then this command will tell R2 to be the source of the default route information and propagate the default static route during the next OSPF update. It will propagate this to all other participating routers. Okay, if you set this default information originate in R2, the next OSPF updates, the R2 default static route will be shared and it will be configured to other routers. Right? So let's say, look at this example. In this example, R2 is configured with loopback to simulate connection to the internet. Okay, so the loopback interface, we pretend that that interface goes to the internet, our ISP. A default route is configured and propagated to all OSPF routers. Of course, in the reality, instead of loopback, we have that real physical interface connected to our ISP router, right? But here we don't have, so we just create a loopback to simulate it. So interface loopback one, IP, we give it IP address and the real network address, not host routes. So 252, this pretend to be the route to our intranet. So that means if routing table cannot match anything, that means we assume that it's going to internet. So the default route should be this, right? Right? Everyone got it? We pretend that this interface loopback one is going to the internet. So this is the IP address for this interface that supposedly go to the internet. So
Oh, so
yeah, so that means if we try to route anything and we cannot find any network in our routing table, normally we assume, oh, that's not meant for our networks. Okay, it's meant to be network somewhere in the internet. So this is our default route. So in the R2, when we say, oh, this pretend to be our internet connection. So my default route, of course, go to this connection. So IP route to loopback one. But we also want all the routers, if they cannot match their, routing table, also send to this address, because we we pretend that this address is or this network is the ISP, right? So we also want to propagate this. Now, without propagation like this, without this, you have to go to each router to set this default route. Yeah, you have to go to router 1, router 3, and you have to type that in. But if let's say you type in R2, since R2 is where we set it first, and then we say for all routers participating in OSPF10, default information originate means this will be shared, and all the routers will add this entry, default route entry, into the routing table. So that means this is a shortcut way for you to say to specify the default route for every, if they are all share the same default route, to share the default route with every routers. Okay, so simply by typing default information originate. Right. So now let's verify. So if we verify, we go to R2, of course, we can see, oh, okay, directly connected to back one. That is our default route. Then we go to R1, we see gateway of last result is this going through to this interface, going to that network, which is 0000. So you can see 000 via, right? That means the routing info, the default routing information is already set, okay, automatically, because it's using the OSPF, right? Is that okay, everyone?
Okay.
Yeah.
Okay.
Okay, so you know that we always send and you guys can participate also, right? Uh, how you see it as a university college, can we always send our students who are good in CCNA like this, especially if they already done ACN, to compete in the challenge, the whole of Malaysia challenge on Cisco challenge on the CCNA. So usually we keep winning lah, either first, second, or third lah, but usually first or second. And one of our instructor and also the lecturer that always guide the students who go for this competition, yeah, uh, keep mentioning that because of this command, sometimes it costs us to win, because a lot of the other participants, they forgot to set the default route. Okay, if they set on one, they forgot to set on the other one, or other routers. So just simply by typing this, you don't have to worry, because it's propagated. All this info, this default route is propagated to all other routers. You don't even have to remember to configure this on other routers. It's already there because of this command. She said that there was one instant where uh, our our student won because of this. Okay, just a a bit of uh, example to show you that even one command like this can make a big difference. All right, so now it's verifying single area OSPF. So basically, after you do the configuration, you need to know the commands you can use to verify lah. So here we can see show IP interface brief is still very good for us to see the configuration done on the interface. Show IP route, show our routing table. Okay, IP OSPF neighbor, IP protocols, IP OSPF or IP OSPF interface. Okay, later on when doing our practical, you can type this, okay, to see what information is given. Now, going back to all the slides just now, we always highlight the fact if we type one specific command here, what is usually highlighted in yellow, what command are you supposed to be looking out for what particular reason? Okay, this come very useful when you are verifying your configuration and also to find out or troubleshoot where is the problem. Let's say you configure already, yeah, confidently you configure, but then still got error. So you might use all this command to basically find out, okay? And check out the yellow colored because that highlight shows you, okay, because there are a lot of info coming out just to pick up the certain info that you need. Right, so verify OSPF neighbors, show IP OSPF neighbors shows you the adjacent neighbor via and what address and via which interface your router is connected to. Right? Okay, so a non-BR, DR or BR router as a neighbor relationship with another non-DR, it will show two-way adjacency rather than full. So full means either one of these is BR or BDR. Okay, you can see here a way to detect just by looking at that, right? Right, so the two routers may not form adjacency, neighbor adjacency if the following occurs. Subnet masks do not match, causing the routers to be on separate networks. Of course, if they link to each other, those interface must belong to the same network. This is misconfiguration. Okay, when you configure your on hello or dead timers value, you have a typo and they do not match, then again adjacency doesn't work, right? Network types do not match, again will not work. Missing incorrect OSPF version 2 network command, earlier we did it. We can use the quad 0 command, right, also. And if you it's missing, you didn't set it, or it's typo again incorrect, then adjacency doesn't form, right? Here we verify OSPF protocol setting. So type show IP protocols. Again, the highlighted part, the yellow highlighted part is the ones that you should be aware of, right? So you can see it straight away, you know, okay, so we are using OSPF 10. So all must be using OSPF 10 in the same area. We see the router ID for R1, okay? Routing on interface configured explicitly for area 0. We use this one is this one lah, right? The network command. Loopback gigabit 1 gigabit port 0. Routing information sources, the two gateways and the distance the cost, right? Right. Okay. So show IP OSPF show us different. So our area is backbone. Area 0 is backbone. Remember, I said backbone is only one of OSPF. We are now just using single OSPF, so we only consider the core OSPF. So usually that is considered as backbone, right? Shortest path algorithm is executed 4 times. It means it's basically using the, remember OSPF finding the path to insert inside our routing table is using shortest path algorithm. And for SPF, the metric is using the cost. The lower the cost, the better, right? Routing process OSPF 10 with this one to identify lah router ID in OSPF area 10. Sorry, OSPF 10 to identify, but in area 0. Right? Right. Show IP OSPF interface shows again. You can see this process ID is the OSPF process ID and the router ID, and this one is important. Whether our router is participating in a point-to-point or multi-access network, right? So Point to point means we are connected directly to another router. So correct lah here, neighbor count is 1, adjacent neighbor count is 1. And the other router ID is 2222, right? And of course, we still have hello, so there's no suppression of hello. Passive interface will be suppressed hello, right? All right. To get a quick summary of OSPF version 2 enable interface, use the show IP OSPF interface brief command, right? So you can see here, right? This is what is shown, interface that are participating in OSPF, networks that are being advertised, cost of each link, network state, and number of neighbors on each link, right? So these are all the commands that you can use for verifying your configuration for OSPF. All right. Okay, so we've ended our lecture. Okay, so these are all the practical consideration later. Okay, what did I learn in this module? These are the list of our topics, quite a lot. Huh? The topics you can see all the way to four slides. So there's a lot. So that means to retain all this information, you guys need to don't delay too long. Need to go back through the slides and also the information online in NetAcad to solidify, because right now it's short-term memory. Okay, to solidify it so that it becomes long-term memory, which you need for your test and your exam, right? You need to do revision. Okay, you need to revision in the next 1, 2, 3 days, so still fresh. Okay, read through your materials, your notes, okay, your slides, and also online. This will help you to retain the information you get today. Okay, right. So I'm gonna stop here. Stop our recording. All right. So now we are actually into our tutorial. All right. So what I'll do is before we start on our tutorial, we will go for is 10 minutes break okay with you guys? Or do you need longer?
Okay.
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 10 minutes okay, huh? All right. So we start back at 3:10. All right, guys. As before, previously, we do our tutorial this way, right? And during face-to-face later, I think we'll decide how um, we can do the tutorial for face-to-face. But for online, we'll continue doing like this. Okay, so the tutorial I've already divided into section where you asked to do lah. I put your name there, and as usual, I'll try to answer anything that you have a question, right, regarding the question, that let me know. Okay, try to help. And at the same time, I will go through and make comments, make comments on, see whether it's partially correct or incorrect or correct. Yeah. Hello. Okay, so Farah, I will bring you out to a breakout room. I need to talk to you about something about your receipt. Okay. Hello, can I speak with Yusuf? Salah nombor. Oh, okay, okay. Thank you. So, get Yusuf. Oh, yeah, Yusuf. Siapa dong? Di
Sir, got no time. The time finished. The time to finish.
Yeah. Sorry. Okay. I will continue to mark it. All right. I will comment it also. Okay. Thank you, everyone. Thanks, Kevin, for letting me know. I was busy attending other things just now. Um, yeah. Continue to do it as part of your homework. Yeah. I will try to also ready the second tutorial for you. Okay, so that we can discuss next week. Obviously, this one we will also discuss next week. Lah. All right. Thank you, Kelvin, Noel, and Farah.
Thank you, sir.
Okay,
Thank you.
sir. Thank you.
Bye bye.